Yeah, hello. Good day, everyone. I hope you guys have all been doing great. So, just trying to set this up here. Um, the purpose of this tutorial video now is that I want to um, take a little while to explain the concept of deploying a serialized model on the web platform. During the course of our last lecture, that is the one we had yesterday, that's on the 1st of April, the one we had late in the night. I tried talking about um, the, um, the aspect of data modeling in classification taxes, and I tried explaining what future selection is really all about and how we could do future selection making use of a machine learning model, specifically the random forest model there. And then after talking about that, we also talked about the various classification metrics. So we talked about the confusion matrix, the accuracy matrix, the precision matrix, the recall matrix, and the F1 score, which is used to find the counterbalance that exists between both the precision and the recall. As we rightfully stated, that there's actually a relationship now, there's a inverse relationship between the precision and the recall, such that the higher the precision, the lower the recall, and the higher the um, recall, the lower the precision. So there's this inverse balance that exists between them, and F1 score helps us to maintain that balance. So we just tried giving an overview of all of these subjects. What I want to do in this video is to explain what the processes of pipelines, creating pipelines in machine learning is really all about, because at the beginning of the video we talked about creating um, performing a series of functions that prepares the data for the model, and then at the end we said we'll create a form of pipeline that will actually do this whole process for us. That is the data cleaning, the data preprocessing, the encoding, and everything that has to shadow with preparing the data for the model and then fitting it. That is, the pipeline is not going to be responsible for the model selection. This model selection is a process all on its own, because when we select a model, we'll place it at the bottom of the pipeline to make prediction after the data has been preprocessed and prepared for the final stages of the model. Now, I'll just jump straight, I think, to here where we started talking about the various metrics, yeah, for performing the. Why is this so error always occurring recently? So we talked about the various metrics for classification, and we talked about the confusion matrix, how the section above here represents the actual prediction, and the section at this point here represents the predicted value, and how this is the comparison of what the true positive are. The true positive rather represents what the actual value is, and um, what the predicted value guessed. And if let's say the actual value is a positive now, that is assuming that 1 represents a positive and 0 represents a negative. So if the actual value is 1 and the predicted value is 1, that is said to be a true positive. And if the actual value is 0 and the predicted value is 0, that is the actual value and the predicted value is 0, that is a true negative. And we talked about how these two constitute to um, making the accuracy formula, which has to do with the true positive plus the true negative divided by the overall number of the set, which is the summation of everything in this box. Because there will always be, the data is actually divided into the four, this thing based on what the prediction was um, compared to the actual value. So skipping ahead, yeah, since I've already summarized all of this stuff, and I am in our class that we took on regression, that was last week. We talked about the process of splitting a data for the training and the for model selection rather. And after selecting the model, you perform the process of fine-tuning the model. And I talked about how fine-tuning a model is not a complicated task. That the reason why we fine-tune model is to just look for other hyperparameters that we could change in the course of evaluating the model now. Different hyperparameters that we could change, and I think I did something there. Although this is a voting classifier, it's a combination of two different models. That is the logistic regression model and the random forest classifier model. And these are the hyperparameters for the models now. We tried placing different values in each of the hyperparameters to like tune the model to see which of these parameters work best for both of the for both of the classification models now, because both the logistic regression and the random forest classifier, they are both classification models. So at the ending, the grid search, after fitting the data, it was able to generate what the best parameter should be for here. So it says for the, because I believe most of the parameter here upward, okay, from here upward represents the logistic regression. So it said the value of C for the logistic regression should be 10, the maximum iteration 1000, penalty none, then the solver LBFGS, which is the solver that I'll be using. Then for the random forest, the maximum depth 7, maximum future none, then the number of estimator 50. Now the voting classifier combines these two models and is able to make prediction that should be able to generalize on new instances if seen. And that's what we decided should be the final model. And just to point this out, the I just wanted to say this before I forget though. There are going to be 10 videos now at the end of this course that has been added to this. That is if I'm done with this, that will have in the archive for the data modeling. And I numbered them 1 to 10. So it's data modeling 1 all the way to data modeling 10. The purpose of these videos and the materials is that you use them in conjunction with one another. Everything that I'm going to explain here, I've already written in the notebook, and everything that is written in the notebook, I try my best to explain. The goal is that you are able to actually learn at your own pace. So the materials in the notebook with the video and then with your intuitive abilities, we could incorporate all of this stuff to um, master most of what I've explained here and make use of the notebook as a form of guide, something that will make the learning process faster. So after deciding on the final model to make use of, we talked about the pipeline now. Now that we are done with fine-tuning the model and the rest. Now that is the final step. We've already known that okay, this is what we want to do when we clean the data. These are the several features that need to be scaled, the features that need to be encoded, that is the categorical features and the continuous features. So we take note of all of these changes that we've made from the beginning, and then we have to create a pipeline to perform the final function. Now, there are actually two ways to do this, and that was something that was brought up in the class from yesterday. We talked about making use of a function-based format to actually preparing a pipeline. And what that means is that all the steps that we've done, all from the beginning here on preparing the data, will create a function that will actually clean the data. All right. So it's just like what I've done in the this particular package. Not here. That would be the loan prediction.py, yeah, the Python file. So this particular function here prepares the data set for what's the name now? At the end, this particular function here prepares the data set for evaluation by a model. That is by encoding the various parameters and filling all the necessary parts if necessary, and filling all the columns that doesn't have a missing data. I should just quickly update this because there was a feature we had earlier that wasn't complete, and that was the married future. It had values that were actually missing. So we would apply that, and I will update this to that's filling the both the gender, the married, the dependents, and all of this. So what we just did here is like a rough way of actually filling the data, and this should still be effective, but still it's not the most recommended. Um, so at the end, what this will generate is a clean data, which is something we'll see around this section of the notebook. After we call the preprocess function, which which prepares the data by encoding all of the values and just having a value that the model can now work with. Given that our model actually works with continuous value, that's numeric values rather than categorical values like say y and semi-urban and rural and all of those values. The models can work with it, so it needs to be converted to a value that the model will understand. After highlighting this difference, you could just create a making use of this function now that prepares the data set. You could just go directly to um, imputing your function behind it, like directly behind it. And the reason why, sorry, that's impute. When I say imputing now, you'll be imputing your model directly behind it by saying maybe at the end of the process of converting this data now to numeric values that the model can understand. You could take the model that you've prepared at this session here, this the final model after fine-tuning the whole parameter. You take the final model, which is this, the grid slash the best estimator, and then work directly with that model. So you just like mix both the function and the final model together to make predictions. But the reason why we've said that method is not accurate is because um, in the course of events, there are bound to be changes. And for instance, in the and if in our analysis here now, you realize that the column gender actually had no missing value. If you were to okay, no, not gender, I think it's the married. No, married had um okay, it's the education that had no missing value all the way from the start till the end. It actually had no missing value. But um in a scenario where you were actually training the model, and when you train the model there were no missing values in your function. Now your function is more likely to negate that occurrence that and outcodes the outcodes the way it encodes all of the values. So in what I mean by this is that every time you call your function, it assumes that the education value is always going to be predicted, is always going to be present rather. The education future column is always going to be present. And because of this, um, it takes no measure for any missing education. And this can cause a real issue when you are trying to make prediction. So we make use of a pipeline in such a way that we can actually handle all of these changes from the imputing of value that are actually missing to the encoding, future scaling, future engineering, and all of those stuff. And we'll do it in such a way that it affects all column, both continuous and the categorical. So I'll just quickly explain how we did this, because the drop columns, after our analysis, we realized that both the gender and the married um, columns were not so significant to the overall aim of the data set when we're dealing with the future selection. So we decided that we'd be dropping these two columns. Even though they're categorical distinct column, they provided very little information to what our final aim would be, which is predicting the loan status. And what that means is that the gender and whether the person is a male or a female, or the person is married or not, isn't really relevant in predicting what the loan status of that person would be. So that's just what the analysis gave us. That's when we were doing the feature selection. And we talked about how these three are actually the continuous column. And by continuous, we mean that their values are not categorical. That's the applicant's income. They always have changing values. So you see that there's no real pattern among the listing. And yeah, we talked about whenever you see a zero for the co-applicant income, it just represents that the applicant has no co-applicant. So they just place the value zero there. So you see that there's several zeros there, but aside from that, there are a lot of continuous values among the distinct data. And then there's the loan prediction, which is another continuous value. There's the loan amount term as well, which looks like a continuous value, but it's more categorical than it is continuous. And you can tell because there is a series of a specific number, then 180. And at the end, we were able to investigate that these numbers are actually broken down in terms of 60. So there's 60, there's actually 120, 180, plus another 60 giving 240 and 300, 360 like that. So it's broken down in terms of 60s, which means that it's actually a categorical data set. So after separating the future columns into the sets that they imply, so we have the columns we wish to drop, the continuous column, then the categorical columns. That's splitting our data sets now into the future columns and what each future columns infer. So after doing that, we'll create a pipeline now, actually two pipelines, one for the continuous columns and one for the categorical column. Now for the continuous column, we talked about how we need to fill every missing value for the continuous column, whether they're actually missing in this data set, or they'll be missing in future data set. And the means that we wanted to use to fill every missing column is by imputing the mean of the overall value when training the data set. So the strategy we made use of is the simple imputer. Now the simple imputer is a scikit-learn imputing function. I think I'll just call it functionality. Yeah, it's a scikit-learn imputing functionality, and you find it in the impute module called simple imputer. And what this does is that it takes a strategy that you want a specific future column to be filled by, and fills every missing future by that strategy. And let me just quickly explain what I mean by that. Now, this is the simple imputer. It says, okay, what strategy do you want to use to fill any missing future column? And most of this stuff that I'm saying, you could always pause the video if you are like following it up with your system and practicalize it to quickly get what I'm talking about. But what it does is it quickly takes it takes a column, all right, and it says, okay, what strategy should I use and fill a column? Then it's in here we specify that I should make use of the mean. So whenever it takes a particular future column, it says, okay, what's the mean of this future column? And anytime it sees a missing value there, it imputes the mean in that missing value. It works by making use of the dot fit and the dot fit transform, just as we did with our label encoder. You could either say the fit or you could say the fit transform. So it works just like the label encoder, the ordinary encoder, the standard scalar, and all of this stuff. They all have three methods in common. Right? They have the fit method, they have the transform method, and they have the fit transform method in common. And that is what the pipeline is actually based upon, in the sense that every model that will be passed into the pipeline must all have these three methods in common. So it must have the fit method, it must have a transform method, and it must have a fit transform method, because it will actually be performing transformation on the model. So after filling the mean value into the continuous variable, we want to also scale them. Now this is not really necessary, but you could also apply it. I just did it for application 6. So every variable, continuous future column is always scaled at the end of um, the pipeline for the continuous columns. Then for the categorical column is the same, if not similar. The only difference here, there are actually two differences here, is that the strategy we want to make use of to impute the missing values for every categorical listing is the most frequent data. So, for instance, with the loan amount, then assuming that 360 is the most frequent data, whenever I see a missing value here, it imputes the value 360 into it. So that is the strategy we are making use of when we talk about the simple imputer. I could just research like most of the time I like making use of the scikit-learn official documentation to review most of this stuff that I'm saying. So you could just review the scikit-learn official documentation and you'll see um, the strategies that there are actually various means of filling these values. So there's the mean, there's the median, there's the most frequent, and then there's the constant. If constant, then replace missing value with fill value, which is going to be a particular value that will be provided around here, which is most likely a string. So for instance, if you want, let me say you're filling a categorical value, maybe a series of authors now, and there are some missing authors, definitely you don't want to maybe fill the missing columns with authors that are not from the listing. Um, you know that authors actually publish books. So my point is that you don't want to fill a wrong author to a particular book. So for those kind of this thing, you can place a fill value like no author or something, and then you say the strategy equals constant. So it's just there are different ways you can actually meddle with these classes. So after that, we perform a scalar function, which maybe is not the wrong term to call it. Maybe we should call this encoder. But what this does is that it encodes the categorical variables. And we've already talked about how versatile the ordinary encoder is in such a way that it kind of scales to different forms of encoding. That is, it's the middle form of encoding between label and one-hot encoding in such a way that it can actually perform encoding on categorical variables that have over 1,000 unique values, and it can also scale those that have only two values, and it does this in a manner that is more feasible, that doesn't really take much memory space for the computer when we are actually trying to fit the data into the model. So after performing the pipeline that actually do this, we talked about the column transformers, which takes this particular stage now. It takes the various columns that we kind of like highlighted here, and it performs several functions on them. Now, all of this stuff that I've been explaining here for the categorical and for the continuous, it now does this here. So this is the continuous transformer pipeline. Then it takes the continuous column and basically transform it, making use of this pipeline. And it does the same for the categorical, transform it, making use of this pipeline. And then for these other two columns, it drops them because we listed that we wanted to drop a column. And you could say that the making use of this scikit-learn dot what's the name again? Compose dot column transformer. That's the column transformer. So if you were to open this now, you will see that there's series of documentation of how it works. So it takes a list of tuples as the transformer, which is what we have here. This list with series of tuples within it. And in each of these tuples, it takes the first thing, which is a name that is in form of a string. That's the name in form of a string. Then it takes the transformer, which is an estimator, something that can be here, which could be either a scikit-learn model or a pipeline. It takes one transformer because pipelines at the end are actually transformer. They transform the data from one form to another. So if let's say you have no transformer, you can then make use of the term drop or pass through. If you if you pass drop into the transformer, it drops those set of columns that will be provided, which is the final listing. And if you make use of the term pass through, those columns pass through the transformer unaffected. That is, nothing really happens to them. It just goes through the transformer the way it is. That means like it is not transformed in any way. So that's for the column transformer. So after creating a transformer for this thing, columns, at the end of this particular um, column transformation here, we get something like this for the data set. Just that, based on we applied a standard scalar for this future column, this and this, the values appear more skewed in nature, in the sense that this value might be something, say 1.2 something. You understand? It will reduce the weight of these values. It will reduce the weight. This zero might be even have a value of negative something, because standard scalar is not a min max scalar, which scales the value in the range between negative 1, and which scales between 0 and 1. Min max does the scaling between negative 1 to 1. So that's for the standard scalar. That's for the data transformation. At the end of this data transformation, a couple of the next thing we want to do is we want to create our final model pipeline. And what this final model pipeline does is that it takes the um, data transformation column, which we um, specified here, storing it in the variable data transformer. It takes it, uses it to make the transformation. That's changing the whole data set from its raw form to a preprocessed form that the model can actually work with. Then it takes the predictor as well, which is the final the final step, where the predictor takes values that the model recognizes. And once it takes this to, it makes prediction. And it just works the way you would do a normal prediction. And what I mean by that is, after you split your new data set now, if you realize we reloaded our data set to still have the um, strings of male, yes, and all of the values that the machine learning model doesn't recognize and all. And after doing that, we splitted the data set, making use of the twin test splits, which I'm sure you guys are already familiar with by now. After separating the data from the target, using the target will be the loan status, and then the data is the every other future column. Then we splitted the data into the X train, the X train, Y train, X test, Y test. Then we for the target values now, given that at the end of this each target value, you still have Y, N, and Y for yes and N for no. It's next thing we need to do is encode those values, because the target value always needs to be encoded separately, because during the transformation process we didn't actually perform a means of encoding this value. So come here and create a new mode of encoding it, which is going to be making use of the label encoder, which encodes both the Y test and the Y train. Then we make use of the pipeline which we created early on to um, train the model. So we just say this dot fit, just as though you are fitting a random forest classifier, or you were fitting a support vector machine, or whatever form of machine learning model. You just say the dot fit, place your training data and your training targets, and the model actually does the um, imputation of missing value, it does the scaling, it does the um, encoding and everything, and it just prepares the data for the target model and for making prediction rather. After after making all of those predictions, we move to the final stage, which is making the prediction now on the test data. So what this does is that when the final model, it just makes use of the dot predict. As I said, it's like making use of your normal machine learning model. As I said, just like making use of your normal machine learning model, just that This model now does a form of preparation for the data and then scaling and encoding and all of those stuff all in one, and then it just goes straight. So basically a pipeline is like a model, but it's a model suited to a specific kind of data. And what I mean is that this particular pipeline now can only work for our loan prediction data set, and it can't work for any other form of data set. So basically at the end it can only predict two value, yes and no, provided it has this series of inputs: the gender, the married, the dependent, and education, and all of this thing. So that is just all for the the pipelines and column transformer. So the final stuff that I want to do, which is the like main of this topic now, is um, how to take this model and make use of it elsewhere. And the way we do this is by serializing the model. Now there are various libraries or tools now that can be used for serializing model. One of them is the one that I just made use of here, which is called Pico. You can there are also others called, I think there's one called JobLib. I didn't say JobLib, I don't know, but I think JOBLIB. So that one too is another serialization tool. And what we do with the serialization tool is that we take a Python object now and we convert it to a file, something like this. That's the .p. Converting it to a file that the model can later on be loaded into the can be later loaded again into another Python package or package that we'll be using to process the file and then used. So what I'm trying to say here is that this particular model that we have here, this loan predictor model pipeline, what we created that does the fitting, the transformation, and everything, can now be stored outside of this notebook. So we can store it outside of this notebook and use it in another environment when we wish to use it. The process of doing this, storing it of outside the notebook and then reusing it, is what we just call serialization. So after storing this particular list in notebook, I created a short application, web application that we could use to practicalize all of this stuff. And the way this web application works is that it takes various inputs such as the gender, the dependents, the education, the applicant's income, and all of those stuff, and then making use of the pipeline which we created here. It makes prediction of what the output should be, and it's something we can actually verify at the end of the thing. So I will quickly open the node. I'll open the software in a bit, but I just wanted to show you guys um, the test value that I want to experiment out. So basically, assuming we've already trained our model now, this is what we want to test out. And given that we've already trained our model rather, this is what we want to test. I want to check, given this value of x, alright, that's the gender is this, all the way to the property area being this. We want to check what the output of the model will be. Would it be yes or would it be no? And I'll just quickly run all of these cells. So while I open my listing, so this is the project, and I will be linking this to the another GitHub repo. So anyone that is interested, I've listed out the various ways you could actually install the project on your local machine. Install the requirements, and you'll be able to test it out for yourself. And one thing I want to be as an assignment for you all is that you could take create your own pipeline, all right, and test it out with this thing. But what we'll be doing here is we'll just quickly run the server, the model server, and we'll test it out on our local on my local machine. So I just want to show you guys how it works. So this is the project. So this is the project, and what I want to do now is, okay, they say the objective of this program is to evaluate the operation of a pipeline on the loan prediction dataset, which completes our data modeling operation on for the classification taxes. Now the program implements a section where the Pico serialized model is stored in a database and can be further used to make prediction on new information. All what this big grammar is trying to say is what we've done now. We want to make use of the pipeline now to further evaluate the model on an actual live system, because this is a live system. Just assume like a web platform running online now, where you want to test whether your loan prediction model is actually working properly. So we start by serializing the sklearn model, which is what we did here. Uh, okay, we did that here, where we made use of the dump um, method to store the model in a in the directory data. So this is the model now for making the prediction. We first upload it. Then after uploading the pipeline, we try to make prediction. Now these are just like background details, but I'll quickly upload one model so we all see what I'm talking about. So the first thing to do is to give the model a name. So I'll give it the name simple model. That's the name of this model that we just want to make use of, because our model is not as accurate as we would have hoped for, but at least it's still precise to a degree. Then we choose the model file, and the model is actually located in my directory. I think this, and then that data, that's this is the pipeline. So after doing that, we want to add the pipeline. Now the pipeline has successfully been added to the database, which can now be used to make predictions. So we'll proceed to evaluating the model. Now the model has already been stored, and I will expand this to okay. I'll expand this so everyone could see what I'm trying to show here. So given our model now, we want to impute these values um, from the test data. That is this particular set of value. The model I've never seen it before, but we want it to make prediction. Now the gender is male, and the person marital status is actually yes. So that's the male gender. The marital status is as yes. The person has zero dependents, um, graduate for the education, and self-employed is no. So zero dependent, graduate for, and self-employed is no. We'll increase that. The applicant's income is 908, 9,083. So quickly enter that value 9,083. Then the co-applicant's income is 0, given that the applicant actually has no co-applicant. So the loan amount is 228. That's the loan amount, yeah. Loan amount is 228. 228. And the loan amount term is 360. So we want to pick that value 360 and impute it in here. The credit history is 1, and the property area is a semi-urban area. So the credit history is 1, property area is semi-urban area. So the next thing we want to do is we want to select the pipeline. I had this issue and I thought most of this stuff was already fixed. So I'm pretty sure I fixed this. Why is that? Am I still having this same the last like before? That will be under the forms.py. I'm pretty sure that I did this well. Okay. So I want to quickly just check for the um I want to quickly check for the I want to check the admin to see if the model that I quickly stored is actually present in the database. So yeah, the model is actually present in the database. Yeah. So it should be showing here. So I'll just say control X. I'll quickly reload. So that was the issue. So it just needed to be reloaded. But now you have actually wasted a bit of our time because we have to re-enter those values again. So male yes, 0 graduates no. So 0 graduates no. Then the applicant's income is 9083 9083 083. Then he has no co-applicants. Then for the amount, he has 228, I believe. 228, yeah. So that will be 361, then semi-over. 360, 361, and then semi-over. So making use of our simple model, which is the only model now present in the listing. So we ask you to predict. It actually predicts the value directly above here. So you say the model predicted yes. What is our final result? The final result here is yes. So if we were to, we could actually try out different values too. Say this for the second one, which is 1 1. I'll just run this two. Now the second one is actually yes as well, but for the second one the credit history is actually missing, but maybe I would update this to um work for missing values. But for here now we'll just guess a value. It can be either 0 or 1. So the area is at semi-urban. The loan amount term is 360 and 130. Just impute those values. Semi-urban 360, here is 130. Then for the co-applicants, it has no co-applicants. That will be 4310 for the applicant income. Self-employed, no. Self-employed, no. Is the person a graduate? Yes, a graduate. Dependent, 0 years male. So 0 years male. And we can also say, okay, make prediction now. This model is actually now the model predicted no this time around, but the actual value is yes. So this kind of like give you how the model is actually performing on the new data set. And you could create your own pipeline now. The reason why I created this is so that you could create your own pipeline and perform your own evaluation on the new um, program and see how these things work for yourself on the listing. Now, we've been able to carry this our model that we've been practicalizing with here, and it looks like all we've been doing is just like it's just like a stressful process of watching data train and making deductions and doing this and doing that. But we'll be able to make all of our work, we'll be able to summarize it into a conclusion called loan prediction predictor model pipeline. And we are now able to make use of that pipeline again now to make predictions on the new data. So on new data rather. So this is just um how do I call it? This is like an overview of the whole class now. So we've been able to, I'm just trying to summarize, we've been able to talk about what data modeling is all about. We've been able to talk about why we model data and um, how to model data for both the classification and regression. We talked about the necessity of the metrics because you don't, when you are working with a regression task, what is important now is not the data set per se, because the data set is kind of like the same on both taxes, but the metrics you make use of. So we talked about the regression matrix, which is the MEE and the MSE. Then we talked about the classification matrix, which is vast, like the confusion matrix, which is the most common actually, because it shows you what the model is really confused about. Then there's the accuracy, precision, the recall, and all of this stuff that we try to break down. We talked about means of cleaning data, um, the future selection process, the future engineering process, the future scaling process as well. Everything has been not just documented but also recorded with the videos and everything just compiled now. And then after all of this stuff, we talked about how to create the pipeline. And after creating the pipeline, how to serialize this pipeline to make use of it on a particular platform for testing. You could always test your pipeline here in the file, just as we have here. You could like create a new Python file, maybe here, and load your this thing. And the way you make load a pipeline is by saying the import, the pickle, which is the pipeline and the serialization tool. Say pickle.load, not loan, but pickle.load. Then you put the location of the pipeline, which is the loan underscore predictor underscore model underscore pipeline. This is a really long name, but this is the name of the this is the location. So we open it in a file now. I'll be opening it in this particular file and we'll read binary because it's a binary file. So if we were to load this particular thing, we need to store it in a variable. So we call it this same name because I love maintaining the integrity of the name of the files. So if we load this now, if we ask for the type of this particular value, so you say the type of this thing, you realize that it's a circuit layer pipeline, which means that what we did here was never really lost, but it can now be moved to other projects, and this serialized data can be used to make further prediction. So that concludes the data modeling class. I really hope you guys learned um, um, I hope you guys learned something new from what we did in all of this class, and actually hope it was an intuitive class. I I wish you guys the best, and I want you guys to keep practicing because most of this stuff can actually die in a moment if you don't practicalize them yourself. So you need to keep practicing, and I hope to see you guys soon in the emoji hack. So thank you very much.